Hey guys, it's 907 Rider from the Rigs of Rods forum here. I'm going to be doing a little tutorial on how to make fast cars and rigs of rods with good handling today. I guess I should introduce myself first. My actual name is Mike. I live up in Alaska, and I'm about 3/4 of the way into a electrical engineering degree. So anyways, what we're looking at here is one of my cars called Dirt Ripper lifted, and this is essentially actually the same frame and body as my F1 car. The only reason that I bring this one up is because it's easier to see everything with the wheels dropped down out of the way like that. So yeah, and if you notice too, just taking a quick glance at this, there are no nodes that aren't used. From our wheel stiffeners right here for the rear wheels to, all of the subframe connectors and everything. There are no extra nodes around. And that's really one of the key details about fast cars, is that you want to get rid of as many nodes and beams as possible, use as few as possible. Now the beam structure might look quite complex, but I can explain that too. Essentially, you have to have just enough beams to make the vehicle strong and not too many to where Rigs of Rods doesn't like it, because Rigs of Rods has a fundamental flaw, and that is that it's designed for heavy vehicles, and the more beams and nodes you have, the heavier the mass of your vehicle will have to be. Now, there's stuff that we can do about it to moderate it here in the vehicle section, but one place where we can't really moderate the weight problem is when it comes to the wheels and tires. Rigs of Rods does not like stiff rims and tires with low weight. If the mass of the rims and tires is low, they will explode. So for a lot of you guys trying to build cars out there and you're having trouble getting them to actually load up for the first time after you've made them, what I would highly recommend is that you actually increase the mass of your car well beyond what you want it to be in the very end, and also increase the mass of your tires and rims, so that way you can factor out that that's not being a problem. So anyways, if we go in here and we look at this, essentially what we have is we have a car with independent front suspension and independent rear suspension. There are two subframes, one for the front suspension over here and then one for the rear. Now, I do something that I'm not sure if many other people do when I'm building these cars, but I design them around the fact that they're going to have 3 A-arms per wheel. So you have an upper A-arm, you have a middle A-arm, and you have a lower A-arm. I do that for a couple of reasons. Number one is that all of the weight from the vehicle has to go through these A-arms down to the ground. So if you imagine, your nodes are what have mass, and so all of the mass from all these nodes has to go down through these A-arms, through the wheel, and into the ground. So you want to have as secure of a connection as possible to that wheel. So that's why I design essentially this third A-arm in the middle here that allows me to get a little bit stiffer connection. Now that's the first reason. The second reason is actually what I just mentioned there, is the stiffer connection. A lot of times double A-arms will seem just fine when you're cruising around at low speeds, but if you actually take the vehicle speed up higher, your double A-arm will start to vibrate and move and will cause wishy-washy effects at high speed, and then eventually the vibrations will get so strong that Rigs of Rods as a program does not like it, because it's having to calculate that vibration into the mass of these nodes out here, and the program will crash. So that's why I do 3 A-arms per wheel. And obviously up here in the front, you can connect, your upper A-arms here, your middle A-arms here, and your lower A-arms here. You cannot connect to these outside 2 nodes, because those are what you use for your steering. You can see the red hydros that we have connected here. Those hydros are obviously what steers the tire left and right. Another thing you might be asking is, well, Mike, what's up with this purple band right here connecting up to the outside node on that tire? Because that outside node is the outside of your tire, and that's what rotates and spins. Well, actually, That is a spring, is a shock. So just the same shocks that hold the vehicle up, that's one of them. And if you notice, I actually have them on all four wheels, and there's a reason for that. Basically, even though you have AAA arms, the outside node on that wheel likes to bounce and hop and skip around when you get up to high speed, obviously, which then causes the game to crash, just as I was talking about before. So what you do is you put these shocks connecting up to that outside wheel, and you essentially use those as dampeners to keep the outside wheel from bouncing, skipping, and hopping around a bunch. Now, because they're shocks, you can change the dampening rate on them, and so what I've done is I essentially found a sweet spot to where the dampening rate does not affect the steering. So even though there's a shock connected to the outside out here, it doesn't change the steering or anything like that. It doesn't affect it at all. So you can still steer that tire, and essentially that node rotates, all the way back over here and all the way around the front. But because that's a shock, it can extend and contract with the steering. The next thing you guys might be wondering is, well, Mike, what's up with this wing in the middle? Well, all high-speed cars, you look at F1 cars, anything like that, they all have to have downforce. You have to have downforce on your high-speed cars. So I designed, obviously, just a wing right here in the middle. Now, this is somewhat unrealistic in that with F1 cars, there's a wing out in front and there's a wing in the rear. But the problem is with rigs of rods, the more wings that you have, the more computing power it takes essentially for the car. And when you get up to very high speeds, rigs of rods essentially as a program starts to slow down and deteriorate. So we want to keep the amount of computing power needed for the car to an absolute minimum. So that's why I've done away with one wing in the rear and one wing in the front and one wing in the rear, and I've just gone with a center wing. If you notice, it's not quite on center. It's shifted backwards just a little bit. You can see the center of our vehicle is right here. So the reason why I did that is actually just for when you're taking the car off jumps and stuff like that, you want the car to fly straight, and if anything, you want it to come down a little bit tail heavy on the back. You don't want it to, nose over forward. So I've moved the wing a little bit to the rear to essentially just give it a little bit more tail heavy off of jumps and stuff like that. And the next thing you'll notice that might look a little weird, like, why are these on here, are our wings. So we have a vertical wing in the front right here, and we actually have another vertical wing in the rear. Now I'm going to cut to rigs of rods to kind of show you guys these two wings really quick, and we'll start talking about those. Alright guys, so here we are in rigs of rods, and we're looking at the same exact vehicle that I just had loaded up there. It's Dirt Ripper lifted. And as you can see, we have a front wing right here, and we have a rear wing, or a rear vertical wing I should say, back here. And we have our middle wing right there in the middle. So what gives all of my F1 cars essentially their secret sauce are mainly contained in these two wings right here. If you look at this front wing, you can see the hydros attached to it right here and here. And now watch what happens when I turn the steering wheel. Essentially, that wing dips down. Same thing with right here. Now, what it's doing is it's not just turning left and right, it's actually turning into the corner. So if I were to take say a right-hand corner, what's happening is that wing is it's turning into the corner, and it's leaning in as well. You have to think of it more like a dirt bike or a motorcycle of some sort, but you can see how that wing leans into the corner. What that does is that keeps the vehicle on the inside, because as you guys know, if you enter a corner at high speed, the inside tire wants to lift up. Well, what the wing does is it essentially sucks that inside tire right back down. You can see that the tires turn as well, but what we've done here is we've actually put most of the turning capabilities through the wing and not through the tires. Simply because there's already so many forces going through those tires just with keeping the car vertical and keeping the car at speed, that we want to isolate the forces of turning the car. We want to isolate those solely to the wing. So that's why we use the wing to actually turn the vehicle. The rear wing, I've experimented around with using that one to steer, and it really doesn't work out that well. So the rear wing is essentially locked into place and does not really go anywhere. It just makes the rear end track totally dead straight. That is the sole purpose of that rear wing. And then the middle wing, actually we just pretty much just use that for downforce. There's not really any other use for it. It doesn't have any hydros connected to it or anything like that. I would love it if I could get a hydro in the game that reacts when I step on the brake, because that would allow me to essentially tilt that wing up forward really fast. And if I tilt the wing up forward, that increases the downforce really quickly and allows me to stop the car a heck of a lot faster. But the way that Rigs of Rods is set up, there are no hydros that allow me to tip up that rear wing. So let's go back to the editorizer and we'll talk about this a little bit more. So we are back at the editorizer here, and essentially what I have loaded up here is just the wings of the Dirt Ripper lifted. So over here in the rear of the car, you can see we have our rear vertical wing, and then here in the middle we have our downforce wing, and up here at the front we have our turning wing. So if you look here, you can see we have 0 and 2, these nodes here, and we also have 1 and 3, these other nodes. Now those nodes are actually the top of our front subframe for the independent front suspension, and those are what I call the pusher nodes. So we push off of 0 and 2 here in the front, and we push on node number 64, which is a node that I had to add to the wing. So that node 64 is actually connected to the wing, and as well as node number 65 is connected to the wing. So we push off of that in the front, and then in the rear here we pull and push from node 66, which is mounted to the car, to node 74, which is mounted to the wing, and this vice versa on the other side. 67 and 72 are mounted to the wing. Now you can't see it, but there's actually some more hydros. They're blocked by shocks here. There's more hydros coming from 1 to 75 and 3 to 73. Those give the rear a little bit of a lean in the rear, I should say. But the main thing that actually turns the wing left and right are going to be these nodes, or these two pushers here, these 66 to 74 and 72 to 67. Those pull and push the rear of the wing, and that's what actually turns the car left and right. The other nodes that I was talking to you about, 0 through 64 and 64 to 2, are what lean that wing in, and they keep the car from wanting to flip over to the outside. So what does this mean as far as locking the wing down and attaching the wing to the car? Well, it actually means quite a lot. It means that we cannot have the wing attached anywhere except for one point. It has to pivot all around one point. So that means that the wing is actually only attached to the car on this point right here, number 65. And you can see a lot of the beams actually attached to that point. And that's simply because we have to make sure that point is extremely rigid, as at high speed, that's the one point that takes all of the stress from turning the car. So all of the stress from turning that car goes through that one node when you're at high speed. Now, the way that we keep this wing from vibrating at high speed, because this wing has exactly the same problem as the tires that I was talking about earlier. When you get up to high speed, this wing likes to vibrate. So what we do is we essentially have shocks back here, and those shocks are covering up the hydros, but these shocks back here keep the rear of the wing, because the front of the wing is essentially locked down with being attached here at point 65, and these two hydros up here. The front's locked down, so it cannot really vibrate around or anything, but the rear is totally free floating. I mean, completely 100% free floating. So the way that we hold the rear in place is actually off of those hydros that are underneath the shocks here, going from 1 to 75 and 3 to 73, as well as obviously the shocks there. So as you can see, there are shocks that come down from 3 to 72 and 1 to 74, and then duplicated on the top. So those shocks have a really high dampening rate, and that keeps the wing from wanting to vibrate back and forth once we get up to high speed. That right there is pretty much the complete secret sauce that's behind all F1 cars that I've put out. So if you can duplicate that in any car, any given car, you will have extremely good handling at high speed. Doesn't matter what car it is, how much weight or anything, no matter what, if you can get that in your car, you're going to have extremely good handling. Now, obviously, there are some things that you have to tweak in the truck file to get these wings to work, and we'll go in there and look at that next. So here's the truck file for that car. You can see I have it all laid out, front subframe, rear subframe, blah, 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 blah. You can see that the car has a ton of torque. And then if we go down here, if you notice the nodes section is actually fairly short for such a complicated car, a car that has independent front suspension and 3 wings on it. There's only 93 nodes. So it's actually fairly non-complicated. Next thing we do is I set my beam defaults extremely high. So essentially I cannot break my beams. Now you have to be careful here, because these are your dampening and your spring value here and your dampening value here of your beams. And if you set those too high, your car will essentially explode when it loads in rigs of rods. So it's good to start out with a low number, or you can simply jot down that number there, or go into I'm sure a lot of you guys have this car. You can go into the notepad file and you can just copy and paste that into your own car. If you copy and paste it, you're going to want to delete this Trax F1 beam carbon. That just changes the color of the beams so they're black. And also this 0.03 here, that just changes around some of the other characteristics of the beams. Not really important. Anyways, so we have all of our beams here. You can see the visible ones. And then what I like to do is I like to label them. That also helps you quite a bit if you're going to edit your car, is to label your sections for your beams, as well as your nodes. The beam section is fairly long just because they're at high speeds. You definitely have to have enough beams to hold the car together, essentially. Cameras, side cam, you guys should all be pretty familiar with those. Next thing is wheels 2. I have to use wheels 2 in this particular car. Rigs of Rods just seems to like it better for some reason. I don't know why. It seems to just have preferences. I can't really answer you as to that one. I've messed around with changing set beam defaults on these. It doesn't really seem to have much of an effect. These 99999 numbers, those are just trying to get the braking and deformation threshold constants extremely high on the beams for the wheels. Because if you guys didn't know this, when Rigs of Rods models up the wheels for the car, it uses nodes and beams as well. So when it's doing those wheels, it's all nodes and beams. And then setting node defaults is also another special thing that you guys are going to want to do. Here you can see my set node defaults. I leave everything just default except for the friction coefficient. I've changed that to 1.25, and you can change that depending on what sort of track you're running on. If you set it up super high, your car is probably going to explode, so keep that in mind. Keeping it lower like that is kind of what I've found you have to do in order to keep the car from being totally unstable. Next we get to a kind of a contentious point: the mass of your tires and the rim spring rate, rim dampening rate, simple spring rate, which is essentially the tire spring rate, and the simple dampening rate. Now, unfortunately, the way that Rigs of Rods works, you have to have a really heavy tire. There's just no ifs, ands, or buts around it. Now, extra unfortunate for us that are trying to make high-speed cars, the mass goes up exponentially with the inertia. So the faster and faster you go, it gets heavier and heavier and heavier and heavier. That's why, like on my F1 cars, if you watch, the tires seem to expand. That's because they're just getting heavier and heavier and heavier, and there's nothing we can do about that. Until the developers and Rigs of Rods come out with something that allows the mass to be lower and keep the essentially the stiffness or the rim spring rate high, there's not much we can do. So you just kind of have to play with that to get a sweet spot. These are the sweet spots that I found for this particular car. Now, if we go into my F1 cars, the mass is going to be much lower, and the rim spring and everything is going to be a bit higher. And also, if you look at the radius of the rim compared to the radius of the tire, in the F1 cars, the radius of the tire is going to be just barely larger than the rim, just to try and keep those as stiff as possible again. So I think that's about that for that. Here we have axles. No matter what car you're doing for Rigs of Rods, I always put your axles in there so you can select if you want to open, limited slip, or locked. I highly recommend running any high-speed car in the split mode, where it applies the same amount of torque to each wheel, simply because when you get up to these high speeds, the game does funky things, and in an open differential, it'll send a bunch of power to one wheel 1 second and a bunch to another wheel another second. So that's why I really recommend that split differential. Locked is also useful, but the problem with locked is that you can't go around corners as fast because those wheels do bind up. Our hydros section, one thing at high speeds, you gotta have multiple hydros on the same node sometimes. So here you can see that we have a hydro going from 7 through 39, node 7 to node 39, and right here we have the same exact hydro over again. We do that just because the hydros cannot take the stresses of being at high speed. So if you put multiple hydros on top of each other, essentially they share the load. Going down here to the shocks, you can have a shocks 1 section in your car and a shocks 2. All of my F1 cars I use shocks 1 just because it's simple, and for F1 cars you're not too worried about the extreme dampening and all that. But this dirt ripper with a long travel suspension on it has necessitated that I essentially put a shocks 2 section in. And that's what I've been playing with lately. That's my latest thing for this dirt ripper too. Alright, so next we're moving on to traction control and anti-lock brakes. I've played around with traction control and it doesn't really seem to work too well, so I just left it in there, but I set the mode to off. Anti-lock brakes, however, are completely the opposite. They are an absolute must for any high-speed car. I highly recommend having an extremely high pulse per second rate. And yeah, next thing's gonna be wings. So you can see this top wing right here is that front steering wing, and if you look here at the end, the multiplier is 1200. That's a necessity for these fast cars. You have to take the multiplier up extremely high. Now, for like my F1 cars, I have the multiplier set a little bit lower, simply because you're at a higher speed with those F1 cars, so the wing is has more air moving around it essentially, so it has more effect. But with like this dirt ripper that's going slower, you don't have as much air moving over the wing, so you have to take the multiplier up for the wing. So that's why the multiplier is set to 1200. The rear wing, I have the multiplier set to 700, and the downforce wing, now this is extremely important, the downforce wing does not need nearly as much of a multiplier. I have that multiplier set to 35, and that will actually vary depending on how you set your wing up. If you go in here and you look at my wing, you can see the angle of the wing right here down as compared to horizontal. Here, I'll get totally horizontal. So you can see the angle down right here. That is what will change what your multiplier needs to be in here. If you have a higher angle down, then your multiplier will not need to be as high. Now if you have a shallower angle down, your multiplier will need to be higher. So yeah, just keep that in mind. The next thing that we have here in the truck file is going to be the fuselage drag. That's also pretty essential for any high-speed car in rigs of rods. It just uses two nodes, one at the very front of the chassis and one at the very rear. Now what it does is it essentially models all of, let me see, I'll show all nodes really quick. Okay, so what it does, you can see node number 76, that's going to be my front node, and node number 77 back here is going to be my rear node. What it does is it takes and it models a wing up and around your car, right? And so it makes the car essentially go through the air faster. Alright, so we've just got a couple more things to go through here. The next thing is going to be camber, caster, and tow as it applies to these high-speed cars. Now, that may not sound like much, but it's actually really important. If you look at this car here, you know, my off-road, which is essentially, like I said, the same thing as my F1 car, you can see these lines right here for the tires. They're essentially they're angled out, and they're also angled up. Now the angled up part is just a structural thing that I do. You can do it. It doesn't really make all that much of a difference. I was having trouble with this front node dipping down here, but anyways, that's neither here nor there. You can do it if you want. It's not necessary, but camber, caster, and tow is very necessary. Now you see this beam right here, this little small guy. I can't zoom in anymore, otherwise I would. Anyways, this little guy right here is actually your axle that your tire rotates on. Now you can see that's angled, you know, back essentially. Now also, if we go over here and we look at it from the front, you'll be able to see that these guys, you see these, they're actually angled out just a little bit. So that all changes the handling characteristics of the car. Now what we're looking at here are some very finer points to the handling of the vehicle. So the reason why the front tires are angled out, so if we go back over here, I'll do a little drawing. Okay, so we have our car is going to be, I'll do it up here in this corner. Okay, our car is sitting here like this, right? We have our A-arms coming down, okay. Now we have our axles are like this, right? Okay, they're coming out and they're actually slightly up. So there's a little, my little terrible, so the ends of your axles are actually going to be up. Now what that does is if we were to like draw our tires on here, I'll draw the tires down here below. So like in the game, this is what the tires are going to look like. Our tires are going to be angled. This is like way blown out of proportion, but our tires are going to be angled like this, right? Okay, way blown out of proportion. This is like way overkill, but just so you guys can see it. So our tires are angled like that. So what that does is that makes it, when we come into a corner, that makes it want to actually corner better. Now, like I said, the way that you get your tires to do that, now you got to remember that this axle right here, there's a node right here on the end of this axle, and there's a node right here. Well, you leave this node right here, you leave that stationary, and you essentially just kind of pick up this node right here on the outside. You take in, instead of going just straight out with it, you just pick it up a little bit, and that gives you, you know, your cambered in essentially at that point. That gives you your camber for your tires. The next thing we're going to look at is if we had a top-down view on the front of the car. So we've got our axles. I'll just draw the axles essentially. Our axles are like this, right? Now that's a standard axle setup in rigs of rods. Everybody just does, you know, you got your tires right here, right? Your front of your car is facing that way, and the rear is back here. Okay, so your axles are like this. You're looking straight down on the car. So for the F1 car, you know, body comes back like this, right? And we have our A-arms that go down like that, right? A-arms. Okay. So what I've done is I essentially take, and you see our node out here in the back. I've essentially pulled that backwards just a little bit. So I'll draw the tires for the F1 car right here behind these other tires so you can see. And this is again a huge exaggeration, but just so you guys can see it. So we go, the tires are actually angled just like this. Bam, they're angled out. So what that keeps from happening is, as you're going down the road, these tires in rigs of rods, they expand out and they aren't uniform when they expand out. So a lot of times you'll end up with a tire. So this is looking again like it'd be looking dead straight at the car. So if you have your axles here, your A-arms, tire, A-arm, axle, okay, your tire will be here, right? And it'll end up ununiform. It'll end up deformed out. So it'll get like a little hump out here to the outside. And then maybe this one over here at the same time gets another little, hump to the outside like that, right? So your tires will be all deformed. Well, what can we do to keep that from affecting our steering and essentially causing our steering to wobble? Because when this happens, your steering is going to wobble back and forth like this really fast. Okay, so what we do is we angle the tires like that. We angle it out that way so that it doesn't, it's always pulling to the outside. It's always pulling outwards essentially. So even if these get a little bump to them, it doesn't matter because the tire is still angled out just a little bit, right? It's still pulling in that direction, and this one's pulling in that direction. And yes, they are working against each other a little bit, but the amount that they're working against each other is a minute, minuscule amount. So it doesn't really matter all that much. And essentially you set that up mainly for the fronts. The fronts are the only ones that need that, but the rears need this one over here. So the fronts get this type where the top is essentially towed in, and the rears do as well, but only the fronts get this treatment where they have they're angled out like that. And let's see, I should also talk to you guys about A-arms really quickly. If you're doing an A-arm setup on one of these cars, so you have your tire here, right? And you have your top, or your middle A-arm, and then, so this is your frame, right? And you have your top A-arm, and you have your lower A-arm. Oops. Okay, what you want to do is you want to make all of these angles the same. So you want this angle here to be the same, and you want, if this was to extend up, say, you want this angle to be the same, and you want this angle to be the same, all the same exact angle. And that therefore means that essentially you take your y coordinate here, you take your y coordinate here, and your y coordinate here, and you just figure out how much higher up you want your frame to be, and you make that same, that same change in y between these 3 points. Okay, now if you were to change this and say for some reason you want to change the geometry of the axle as you're going down the road, you could simply do something like this. You'd have one that's going down here, and then you could have a really short like this, and then have only one top A-arm. You have your axle like this. Now essentially what that would do as the tire moves up, your suspension, as your suspension works, it's going to, this one right here is going to hold its place more than the shorter A-arm. So this shorter A-arm will actually pivot in. So when the suspension is all the way down, this might be totally vertical, right? So your tire is 100% vertical and perpendicular, everything's straight with the world, right? Now once it gets up to the top, once you compress it, like say you go around a corner or something like that, what's going to happen is that front, so I'll just draw it extended further out. I'll just do that. Okay, so that top A-arm, so imagine this one's going to be the same length as this one. That top A-arm is actually gonna be like this, and then the lower one, this lower one right here, is going to cause this. Now this is again extremely exaggerated. Is going to cause this to essentially angle in. Now keep in mind that this is all solid right here. Okay. So that means that your axle and therefore your tire is going to be angled down like that. And again, that's when the suspension compresses. So it angles pretty hard, down like that. You can get the same thing by changing it around and making this one longer, this bottom one longer, and the short one shorter, or the top one shorter. It all changes around your suspension geometry. But kind of no matter what, like the go-to thing for this independent front suspension type thing is you always put your center node right here, and then you use your hydros off of that center node to this. So you'll have your hydros boop, 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 coming down like this, and that's what'll steer your car. Now, if you do that and you do like an exactly geometrically the same one, like this one over here, your geometry is going to stay exactly the same as far as like when it's down low like this and when it's up high. So even when this is all the way compressed, your axle is going to have the same exact toe, caster, and camber as when it's down low. So all this might seem like it's a little bit over the top. You don't really need to know it for rigs of rods, but trust me, when you're doing these high-speed cars, it makes a big difference as to where the car handles. Another little tip and trick that I like to use is I will actually include a shock over the hydro on the steering axles. So that way, if you do get any speed wobble, at high speed, it kind of minimizes it and it keeps it from happening. So a lot of times I'll stick, so you have your hydro, you have your hydro coming down here, right? You also have your shock will be laid right over the top of that hydro. Just because there's a hydro there does not mean that you cannot put a shock going over there to it. And actually, if you look at the Dirt Ripper, you can see the stabilizer arms or the stabilizer shocks that are right here. They actually are that's the whole reason why they're there, is to stabilize that outside and to also keep the bump steer from getting too out of control and the speed wobble too out of control. In this car, you can see I have my suspension is set way up here. I do that because this has got a long travel kit on it. So essentially these can come way up there, and this is kind of like my Baja Racer. The F1 cars do not have that. They have a more traditional, at least in the rear setup, there is a shock going from this node right here, number 48, up to the subframe. And then it's the same thing on this other side, from node 48 to 22. And then we also have a shock going from 44 to what would be like 84 and 30. That in the rear, your suspension in general does not need to be quite as complex as for the front. If we want to move into talking about the front suspension, I'll open up this F1-3 right here. Okay, so if we go in here to the front, we can see that my front suspension in this is still that taller type suspension, but there's a reason why I did that. Now, when you come into high G corners, just because the car isn't rolling over does not mean that there is, not still a bunch of G forces going down through the axles and tires. So if we look at the rear here, you can see it's got a pretty conventional setup as far as suspension. It just, triangulates off of that one there to that one, and then it also triangulates off that top node down to the bottom of the frame. The front, however, is where things get interesting. So if you only use one shock in the front, it guaranteed it will break. So what I've had to do here was actually, there are 4 shocks, load-bearing shocks, I should say, per tire on these F1 cars. What there is there's one, so for this tire right here, you can see we have our node number 78 is what holds all the shocks. This node number 78 actually contacts node number 42, node number 40, and node number 38, as well as node number 43. So if you're going to do this, there's a couple reasons to do this. Actually, let me go there first. Node number 78, bracing off of node number 43, helps to keep the stress down because you have to remember that all of the stress from the weight of your car, normally, if your shocks are only connected on these guys right here, all the stress from the weight of your car is going to go down. It's going to go, on the outside at least, is going to have to be transmitted to these three nodes right here through these. There's essentially two beams, right? So again, we get into that thing where there's only two beams holding all the weight of your car on a particular tire. So what I've done is I've obviously stuck with, the essential shocks right here on the inside, but if you center that node, that support node on the top, if you center that node above your node in the middle like this, the way that your suspension will work, it will actually spin around that same axis as this node, and it will allow you to put essentially another shock going out here to this node number 43. Now that node number 43 also has support going to it, right? And because it's pivoting around the same point, this node number 78, it can pivot freely. It's got no restriction to movement or anything like that. So like I said, I would really recommend taking and actually putting a shock out to this node number 43, because the name of the game with this front suspension is essentially supporting it as well as possible. That's why we have these three nodes here all have a shock going to them, as well as node number 43, and then also supporting node number 43 is a stabilizer that comes back here to 83. That just keeps some of the shock and the shock load off of it, I should say. Make sure that it stays in place and doesn't get vibrated around and changed around. So I think that's about it, guys, really. There's not much more to them. Essentially, once you get done with the car, try and lower the weight as much as possible. Get the weight down as low as possible until the car starts exploding when you start when you load up the car. Once the car starts exploding and imploding when you load it, then you've gone too low with the weight, and crank it back up just a little bit more. My rule of thumb is to make sure that your weight is, go to where it explodes and then take the weight back up another 200 kilograms. And that helps with, keeping it stable and everything. If there's anything else you guys would like to know about them, feel free to message me in the comments or message me on the forum.